Segments, Lines, and Angles. Preview video 2.9, Part 2, Graphing Parallel and Perpendicular Lines. Taking a look here, graphing and parallel lines. From our previous class, we accidentally skipped a single page, so we're going to do this now. So last class, very simply, we discovered this, that slope equals slope for parallel lines, and slope times slope equals -1 for perpendicular lines. So this says find the slope of a line parallel to the given line and then perpendicular. Well, being that our slope, we already have it, y equals mx plus b is 7/5, our parallel slope is exactly the same. Our perpendicular slope is the opposite reciprocal. Find the slope of the line parallel to the given line, then perpendicular. This one you first have to get in y equals mx plus b. And our given slope is -4. Technically, all slope is over 1. So our parallel slope is going to be -4 over 1. And our perpendicular slope is 1/4. Don't forget the date, time, location, as well as a parental sign-off. It says here, we're going to do this two problems together, and then you're doing one on your own. These are the most common kinds of questions that you will find on SATs. You're going to write an equation of a line with the given information, and then graph both the original line and the derived line. So we have here, we want a line that goes through 5, 3, but parallel to y equals 4/5 x plus 1. So our original line is this. Let's go ahead and graph that. So we have here y equals mx plus b. Our b is +1. Our slope is 4/5, and it's positive. That's 4, rise of 4. 5. So here is our original line. That's y equals 4/5 x plus 1. Now, our second line says we're going to go through this point. This is our derived line. We're going to go through this point, and we want it to be parallel. Now, there's two ways to do this: graphically and algebraically. The algebraic way is the most accurate. Let me explain. So, and graphically, because it won't always be a whole number. So graphically would be like this. We want a line that goes through the point 5, 3. So you plot 5, 3. It's right there. 5, 3. We want it to be parallel, which means the exact same slope. So we count 4/5. 1, 2, 3, 4. 1, 2, 3, 4, 5. So our second point is going to be there. So let's do this algebraically so we can make sure when we draw this line it's in the correct place. So let's go through and show you how to do this algebraically. We have y equals mx plus b. Our desired slope is parallel. Parallel means we want the exact same slope. So I circle this. I'm going to bring it over here. I want the exact same slope to match. But it's going to go through the point 5, 3. 5 is x, 3 is y. Now we're going to solve for our b intercept. So the equation of our second line should be y equals positive 4/5 x minus 1. Now let's graph that, and we'll see if it matches our graphic. So there's our intercept at -1. Let's count our slope out. I'm going to go this way. 1, 2, 3, 4. 1, 2, 3, 4, 5. That's a rise of 4, a run of 5, the same. You take a look here with our original graph line, and it is the exact same line. Let's try another one. Write an equation of a line, given information, then graph both the original line and the derived, this should be derived line. Okay, our original line is this. So let's first get that into y equals mx plus b form. So our given line is this, y equals 5/7 x plus 2. Let's go ahead and graph that. Our intercept is 2. Our rise is 5/7. It's a positive line. So we have y equals 5/7 x plus 2. That's our given line. Now our derived line, we want it to go through 5, -4, but is perpendicular to this line. Now the perpendicular slope looks like this. Slope times slope equals -1. So it's 5/7 times some sort of slope is going to get us -1. And you ask yourself, what is this slope right here in order to make a perpendicular line? And it is the opposite reciprocal. Because if you multiply 5/7 by -7/5, you're going to get -1. So this is our perpendicular slope. So we want an equation of a line, so we start with y equals mx plus b. Step 1, we want our perpendicular slope right here, -7/5. And then we come here, our x is going to be 5. And our y is going to be -4. So we solve. These 5 cancel. We end up with -4 equals -7 plus b. Add 7 both sides. And we end up with our slope being positive, not our slope, our y-intercept being +3. So our perpendicular line meeting these conditions has a slope of -7/5, so y equals -7/5 x, and a y-intercept of +3. Let's go ahead and graph that and see what happens. There's our y-intercept. Let's count our slope out. That's -7/5. So you can see that this secondary line, 1, it is perpendicular. 2, it does go through the point that we've been asked to find, which is 5, -4. This page you're going to do on your own. Restart the video when you are done. Alrighty, so first you had your given line, y equals -4/3 x minus 4 when you graph that. And then you want your derived line to pass through the point 3, -5. Let's just plot that, +3, -5. We want it to go through this point. But we want it to be parallel. So we come over here, the slopes are the same. We replace x with the 3, -5 with the y. We solve. B equals -1. So our secondary line is going to be y equals -4/3 x minus 1. Let's plot that and see if it works. There's -1. Let's count our slope out, -4/3. So 1, 2, 3, 4, 1, 2, 3. It's a downward tilting line. And there you go. You have the exact same point that we want. Make sure that you take the time to review this material. Explain maybe one of the 3 problems to another person in your family.